Welcome back. I want to close this lesson by looking at vertical projectile motion. I will be moving quite a bit faster. Please follow it up with me. I don't have much time, so unfortunately I have to move this fast. Okay, vertical projectile motion. Vertical projectile motion is an up or down motion of an object. Okay, an object undergoing up or down motion is called a projectile. So if I throw this pen up, we can say that projectile, okay, because it is now moving in vertical motion. Okay, the change in position of a vertical, the change in position of a projectile motion is along the vertical axis, and therefore we're going to use delta y for that change in position. All object experiences what we call acceleration due to gravity, which is the same, which is always 9.8 meters per square second on planet Earth, where we are. Not on Mars, not on the moon, not on any other planet. Every planet has its own acceleration due to gravity, including the moon. So when we're talking projectile motion, we make use of equations of motion to solve problems related to that, okay? So we need to be aware of this equation. V final equals V initial plus G delta T as our first equation there. Second one, delta Y final, okay, or delta Y, so that final should be equal to V initial delta T plus half G delta T squared. And if we look at this one here, V final squared equals V initial squared plus 2G delta Y. And lastly, delta Y equals V final minus V initial times delta T divided by 2. So you can have that 2 there because it tells you is the average instead of having it there. It's just that it was shifted due to our working on the slides. Okay, now graphs of motion for a projectile, okay, for a motion of up and down, okay, objects moving up and down. How do we draw those graphs? Okay, suppose an object is thrown vertical upwards at a certain velocity. Sketch the following graphs for the motion of the object. 1. Displacement versus time graph. Displacement versus time, it starts from 0. This is delta y, this is delta x. It starts from 0, thrown up at a certain velocity. It covers some y distance or displacement. It gets to a point where it reaches its end point and it comes down. So it moves up to that position, then it comes down. So it comes down. Now this is delta t, sorry, over time. So it comes down back to where it was at the position where it was projected upwards. One thing we need to know about this is that this will be half t here. If this is t, this will be half t, okay? This graph, delta t here in seconds and delta y there in meters, okay? So that will be displacement versus time. If I have to look at velocity versus time, look at it here. Velocity in meters per second, time in seconds, let me put it that way. It was thrown upwards at a certain velocity. But as it goes up, the velocity, does the velocity increases or decreases? We see the velocity decreasing, so it decreases until it gets to a point where the velocity is 0, which is at the time when it is to 10 and comes down. So that is t, which is normally half the time it takes to come back to the thrower's hand. So at that point there is its maximum velocity when it comes back, which should be equal to the velocity at which it was projected upwards there. Okay, so that's what we have for VT graph for a projectile. Now, acceleration versus time, what we have or what we see here is that the acceleration is the same. It doesn't change. All objects experiences the same acceleration, which is acceleration due to gravity, g, 9.8 meters per second. So it doesn't matter how long we look at it, it will always be having or experiencing the same acceleration, which is acceleration due to gravity. If you look at this shape here, this is an object going up and down. This is, if you like, you can complete this and say this is a graph of displacement versus time. Okay, it goes up and down. Okay, and then this is the shape it will take. Coming back to this two graphs here. Okay, this graph here, as you see it, like we've moved from this one to the velocity time graph. The acceleration time graph, actually, you can get your acceleration here by getting what we call the gradient of the velocity time graph. Gradient m, which will be change in y over change in x mathematically. Now, change in y will be change in v according to our graph here. Is change in v divided by change in what? Here is change in time where x is. So that you can see already, it gives you acceleration, because acceleration is rate of change of velocity. So if we take any point here, any 2 points here, say these points, we can actually find what g is for this particular motion, what acceleration is, and we can actually find it to be 9.8, confirming the g. That brings us to the end of this lesson. I hope you enjoyed it. Let's meet in lesson number 36.